Hello everyone, this is Charlie from the Bloomingdale Public Library, and today we're going to do an overview of using shader nodes in Blender. So what are shader nodes? Shader nodes define materials in Blender. In other words, materials act like containers for shader nodes, and you can't work with shader nodes without one. So the workflow goes, you'll add an object to a scene, add a material to an object, and then add shader nodes to the material to determine its properties. Shader nodes are used to change a material's surface, volume, and displacement through the material output node in the shader editor. So if you're with us during the geometry node editor course, you might recall we would do a whole bunch of work with geometry nodes, and the results of which would all end up in a single node called the geometry output node. Working with the shader editor is not much different. Everything we do is eventually going to wind up at the material output node, and that node has three inputs, one for surface, one for volume, and one for displacement, and we'll talk a little bit about doing all three. An object's material determines how light reacts with its surface, volume, and environment. In other words, its color, reflectivity, transparency, glow, etc., all things doing with light. Shader nodes' effects can only be seen when you're working in the material preview or rendered mode, the other two modes being X-ray and solid mode. A brief note about that, there are several render engines when you're in rendered mode, one of which does not even use shader nodes, and the other two will treat materials completely differently, just depending on which one you're using and the settings you set within each. And we'll have a brief overview of the various render engines, but we're not going to go too deep into it. One final word, shader nodes are for working with how an object looks in a digital scene, and it's not going to do much for you if you're planning on just working with 3D printing, which was the main motivation for doing these Blender courses in the first place. So if you're primarily concerned with doing 3D printing, you can skip over this course. So before we look at the shader editor, it's probably a good idea to at least take a quick peek at the rendering engines, because the rendering engines and their settings will directly affect how your shader nodes are rendered, or even if they're rendered at all. Even before that, we want to make sure any graphics processor we have in our computer is enabled within Blender. To do that, we go to the Edit menu in the top left here, click on Preferences. In the Preferences, we're going to click on System on the left side here. And we want to look at this option at the top where it says Cycles Render Devices. This basically determines what is doing the graphics processing when you're using the Cycles rendering engine. And the Cycles rendering engine puts a huge processor load on your computer. So if you can offload any of that onto a graphics processor, we want to do that. It'll keep Blender running a bit quicker, and in the case of an older system, it'll probably keep it from crashing. So if you don't know if you have a graphics processor available to use these options, that's okay. You can go ahead and click on each one, and it'll tell you if it finds a compatible graphics processor. So the first option here is CUDA, which is an NVIDIA option, and you can see it says no compatible GPUs found. The next option is OptiX, which is another NVIDIA option. I believe it's a newer option, and there's nothing there for us either. HIP is for AMD graphics processors. We do have a little something we can enable here, so they are checked. And one API is for the Intel graphics processing options, and there's nothing there. So we're going to go ahead, select HIP, make sure everything is checked, X out of there, and we are good to continue on. Okay, so I've got a little scene here. It's just a cube and a plane, and they both have materials attached to them. The cube should be completely reflective, where the plane has a checkerboard pattern as well as a bump pattern. So we're in solid mode right now. Let's go ahead and go into rendering mode and see what the rendering engines do with it. To do that, we go to the little circle all the way on the right, click on that, and this is not exactly what I told you to expect. So by default, Blender will put us into the Eevee rendering engine when we go into render mode. Now Eevee is designed to be quick and interactive, and it's good for previewing things and working in the 3D viewport, but it does have its limitations and it's prone to inaccuracies. So one of those limitations is it cannot handle displacement nodes in the shader editor, and that is how I created the bump pattern that we're not seeing right now. So we can go ahead and get the reflections out of our cube that we're not seeing, but to do that we need to goof around with the Eevee settings a little bit. To do that, we go over to the properties panel on the right here, and the picture that looks like a little digital camera, if you roll over that, it says render properties. When we click on that, we can see our rendering options, and right now you can see the rendering engine is set to Eevee, and all of these options down here are specific to the Eevee rendering engine, and there's a whole bunch here and we're not going to cover them today. If you wanted to use the Eevee rendering engine for creating a final result, you can actually get good results if you go through all of these options and goof around with all the numbers and enable everything. But when you do that, you do lose the advantage of the quick responsiveness. So you can see right off that one of these options is the screen space reflections. If I check that, we get the reflectivity of the cube at least. So I just want you to be aware, if you do something in shader nodes and you don't see the results in the rendering engine, keep in mind Eevee is incapable of some things, limited on others, and for a lot of things you need to go through the settings and actually enable a lot of them. So that is a look at the scene with the Eevee rendering engine. The next one down the list is Workbench. If I click on that, it looks like we're back in solid mode, because basically that's what the solid mode uses. It uses the Workbench rendering engine. However, in rendering mode, we do have some options. Ones to be aware of are for color. If you go to random, it will set a random color for each object in your scene, which can be helpful for just placement and checking animations. Another one that's kind of interesting is shadow. If I click on that, you see we have a shadow of our cube floating above the plane. However, if I start moving around the light source in the scene, you see it doesn't affect the shadow at all. So it's just a cute little thing that you can use with the rendering engine. Otherwise, this is probably not a rendering engine you'll use to create a final result. So from there, we'll have a look at our final option, which is cycles. And that is the big one. So you see, just clicking on it, it takes a second for everything to come into view. But once it does, you can see by default we have our reflectivity in the cube, and you can see the bump pattern that I was talking about in the plane. So cycles is much more accurate than Eevee. It works by doing ray tracing, which you might have heard of if you've been paying attention to video games lately. But that accuracy comes at an extreme processing cost, which I talked about earlier, which is why you want to make sure over where it says device under the render engine options, make sure it's set to GPU compute if you were able to set something earlier in the preferences. Otherwise, you set it to CPU, which will still work, but all of the processing gets put on the CPU, and things might drag a little bit more depending on how strong your CPU and GPU are. We'll set that back to GPU compute. If things are running a bit slow and you want to try to speed them up, what you can do is raise the noise threshold, so it will allow the scene to be a little bit noisier. So I'll set it to 0.5, and you can lower the max samples. And I think it's most helpful if you keep it in factors of 2 or 4. So we'll bring it down to like 32. And then that might help move things around a little bit. You can see in the upper right, or the upper left rather, how many samples of light rays the engine is taking in order to reach the noise threshold that we've set. So that's a quick look at the rendering engines. Next, we'll start taking a look at actually putting down some materials and shader nodes. So the default cube has a default material with a default shader node attached to that. And there's actually a bunch of things we can do with all that in the materials tab of the property panel. So let's go have a look. The materials tab is the little sphere with the checkerboard pattern on it, kind of near the bottom. So if we click on that, that takes us here. At the very top, we can see the object currently selected and the material assigned. Below that are the list of materials available to the object, which right now we just have the one material, and it is named material. If we wanted to change that name, we can click in this box here and give it a new name, and because I eventually intend to make it red, I'm going to call it red. Over on the right side, you can add and subtract more materials for the object. We're going to come back to that in a bit. Below that is a collapsed panel. It says preview. If we open that up, it gives us a rendered material preview, and we can choose a bunch of different shapes to see how our material looks on a different shape. Below that, we have a whole bunch of options, and all of these are properties of the principled BSDF shader node. So this is the node that is assigned to all materials by default, and it is extremely robust and powerful, and in many cases it's the only shader node that you're going to need for your object. And the fact that we can get to all of its properties from the material panel means in a lot of cases we won't even need to go to the shader editor either. So looking at all this, first thing we want to do is make sure it says use nodes highlighted in blue. If you're not using nodes, then you don't have all of the properties of the shader nodes available to us. So make sure that is selected. Now if you decide you don't need to use all of this, like if you know you're working with glass, you can go ahead and click on the principled BSDF node and choose another one for your base shader node. So if we scroll up a bit, we have glass BSDF. We select that, and it simplifies things a whole lot. I'm going to go back to the principled BSDF. You'll notice pretty much all of these properties will have a colored circle on the left side. What that represents is an input socket for that property of the node. So if you were to click on one of these, you can actually assign an input node from the Materials tab instead of going to the shader editor. On the right side, you see all these little gray dots here. These are for assigning keyframes for that property, which deals with animation, which we discussed in a previous video. So let's go ahead and click on base color here, and we're just going to make this guy red. So now you see in the material preview window here, we can see what our material looks like on a sphere. Now if you were ready to start working with materials in your viewport, you can go up to here, and the third circle is the material preview mode, which basically uses a version of Eevee in the viewport. There's a couple other options when you're using the materials preview mode. If you click on the little down arrow to the right of all the circles, you see the environment that it is putting your material in, and you can't really see much because our cube is just red. It's not really reflecting or anything. But if you want to see what's actually going on, what our material is reacting to, you can increase the world opacity all the way up, and then take the blur all the way down, and this is what our material is actually reacting to. And if you wanted to change that, you can click on the picture of the sphere here, and you can choose different environments to preview your material in. It's just a nice little shortcut if you don't have your backgrounds or your scene lighting all set yet. This just helps you get an idea of what your material is going to look like. So we'll go ahead and create another material for our object here. So we're going back up to the top. We'll click on the plus sign here, and this opens up a slot. So in this slot, you can either click on this guy here and select another material from our scene. We don't have any other materials available in our scene right now. So what we're going to do is click on New to create a new material. We'll scroll down a bit, and if you recall, I made a cube that was completely reflective. To do that, we set the metallic all the way up and the roughness all the way down. And you can see it in our preview window. This is what it's going to look like. You'll see it's also selected up here in the list of materials. However, it's not being reflected in our viewport, and that's because you have to actually assign the materials to the faces of your object. So I'm going to go to edit mode here, select faces, and now if I select a face and choose material, you'll notice that these new options appear down here where we can assign the material to a face. And when I do that, you can see the face changes. Oops. Select the new material there, assign. And so that is how you use multiple materials on a single object. So I think that's it for now. I think we're ready to start looking at the shader editor at last. If you're ready to start using the shader editor, you might be interested in trying out the shading workspace. To get to that, you go to the top of the screen about halfway across, you see the word shading. Go ahead and click on that, and it should make your display look something like this. Let's unpack what we're looking at. The right side should look pretty much the same. The middle should also look familiar. This is the material preview mode of the 3D viewport. This will allow us to see the changes we make in the shader editor in real time, which is pretty nice. To the left of that, we have a file explorer. So if we needed to add an image texture to the shader editor, we can go ahead and float through our folders. You go up to go up the directory tree. Left and right, go forwards and back. If you know the file path of the file you're looking for, you can type that in here. There's also a search function, which I haven't used, so I'm not sure how effective it is. To the left of that is directory view options, and next to that is the filter options. Once you find your image texture, and let's say you wanted to do some editing on it, you can click and drag that straight down to the image editor. Now, we've already talked about the image editor a whole bunch in our course on textures, so if you were curious about that, you can go back and check that course out. Now, if any of the pieces to this puzzle didn't make sense to what you're doing, you can go up to the upper left corner of the editor and choose something else. Anyway, to the right of the image editor is the shader editor. And if you were with us for the course on geometry nodes, you probably noticed this looks pretty much the same, and it functions pretty much the same as well. If you wanted to bring an image texture into the shader editor, again, all you got to do is find it in the file explorer, click and drag it into the shader editor, and it'll create a node for you, which is pretty nice. Now, my display is kind of short on space, so I am not going to be using this layout. Instead, what I'm going to do is go to the regular layout and repurpose the timeline. So I'm going to go up to this upper left corner here, go to the shader editor, and now I have a bit more space to work with there. Alright, so I'd like to talk about textures just a little bit. In Blender, a texture usually refers to an image file or one of the procedurally generated patterns provided by Blender, and a texture is used to control the properties of a shader node. Before we go further, I'm going to go ahead and grab one of these procedurally generated patterns. You can find those under Add, Texture, and then you can see a whole bunch of textures here. Of course, image texture is where you go searching through your folders for an image, but otherwise most of these are procedurally generated, where you can control the output a bit by messing around with some of the numbers. I'm going to go ahead and select the checker texture because it's simple and predictable. And now usually when people think of controlling one of the shader node properties when they're just getting started out, they're thinking of just the base color. So I'm actually going to change the gray to black here. And if I connect the color to the base color, again, that's what most people think of. However, you can control pretty much any single one of these properties with an image texture. And all of the input sockets that are gray indicate that they're expecting only a single value, so you'd want to use grayscale image textures for those. So an example where we can use an image texture to control something other than the base color would be, well, let's say I'll connect this up to roughness and set the metallic all the way up. Now you see we have a surface where some of it is reflective and some of it is not. Now let's say you were creating a steel door with some rust on it. You would have a base color where the image would be, say, gray for the steel and brown for the rust, but then you would create a grayscale image that would look very similar to that, where perhaps light gray would represent where the door was still intact and black would represent the rust, and you'd plug that into metallics, so the steel of the door would reflect the light and the rust would not. So as of the posting of this video, there is a texture node editor in Blender. If you go up to the upper left corner, you can see it right here. This is the texture node editor. But be aware, this has been considered legacy for quite some time now, and it's probably going to get phased out in future versions of Blender. So if you wanted to do any sort of texture editing with nodes, you want to do it within the shader editor instead. And if you're interested in doing more work with textures and UV mapping and working with the image editor, I'd recommend you go back and look at the course that we did on Blender textures a while back on our channel. Alright, so let's discuss actually using the shader editor. If you're with us for the geometry node course, this is going to be almost entirely review. So to start off, by selecting a node, all you got to do is left click on it. I recommend aiming for the label up at the top, otherwise you might wind up changing values or selecting colors. To select multiple nodes, hold down Shift and select the other nodes with the mouse button. If you wanted to deselect a node, just hold down Shift and click on it again. If it was not the last selected node, it's going to turn white first to indicate that it's the last selected node, and you're going to have to shift click on it a second time to deselect it. Alternatively, you can click and drag to create a selection area and select multiple nodes at once. We can do that because the selection tool is enabled by default. If you want to see the tools available to us, there's a little arrow hanging out the side of the screen here at the top left. You click on that and you see our tools. So if you click and drag a little bit on the selection tool, you see there's a couple of other selection options available. Next tool down is for annotation. There's a couple of annotation options, and that just lets us scribble on the node sheet. So useful if you want to leave some notes for yourself. The last option in this group is the annotate eraser. Go ahead and select that and use it to clean up the mess you made. The last tool is the links cut tool. So you select that, then left click and drag, and that will let you cut links. So if you have a whole bunch of links together that you need to get rid of, that is a nice quick way to do that. Otherwise, you can also use Control right click. I'm going to go back to the selection tool and then click and drag to hide those tools back in the corner. In order to connect the nodes together, you just click from one socket to another. The colors of the sockets indicate the data type that is being passed back and forth. The colors don't necessarily have to match, but it makes it more predictable if they do. If two sockets are incompatible, they will make a red line and nothing will be affected. So an output value can go to multiple sockets. However, input sockets can only take one value at a time. I'm just going to finish connecting these all up here. There we go, a nice little complex checker pattern on our cube. So there's a couple things we can do to customize our nodes. Let's go ahead and select the big guy here, the principled BSDF. With this selected, go over to the right side and make sure the node tab is selected. And you'll see here we have a name for the node. I would recommend just leaving that alone. Under label, you can give it another name though. We'll call it big guy. And when I do that, you see the name for the node is changed to big guy. If you click on the color, you can change the color of the node. And if you select this bar here, you click on that, so you can go ahead and use the color wheel and give it whatever color you like. So it can be helpful for picking nodes out of your node sheet when things start to get very complicated. Another thing you can do that in this case would be extremely helpful, considering how little space I have, is if you click on the little collapse arrow next to the label of the node, it will collapse the node. And in the case of the BSDF node, that does quite a bit of help. Click on the collapse arrow to expand it back to full size. If you want to work with a group of nodes, you can go ahead and select a group. We'll select all of the checker texture nodes. And we'll start off by putting them in a frame. To do that, we go to Node, Join a New Frame, and you see it puts a box around them. Again, we're going to go over to the right side here. You see it's got the name Frame, but we want to ignore that and instead give this a label, and the label will be checkers. And just like before, we can set a color by checking the box and then clicking on the color bar here to pick a color. We also have this little title here where we can change the label size. So under properties here, you can click and drag on label size and shrink and grow it to your content. If you want to start moving things around, let's say you want to move the nodes around, you see the frame will adapt. If you want to remove a node from the frame, just select the node, go to the node menu, and select Remove from Frame. And this node is free. The other nodes are still in checker jail. If you want to get rid of the frame altogether, you have to kind of go in the background here and select it Then go to Node, Delete, and that will get rid of the frame. Something else cool we can do to help organize things is group the nodes, which is different than framing them. So what I'm going to do is select the 3 checker texture nodes, go to Node, and near the bottom here it says Make Group. When I click on that, it's going to pull us to another window and let us mess around with just these nodes by themselves. I'd recommend just leaving it alone on the screen and going over to the upper right corner and clicking the Up button here. And that'll take us back to the original node collection here, except you'll notice now all of our checkers are squished into a single node. So this node will take a scale value for input and give a color for output. And you can even go another step further and hit the collapse arrow to make it even smaller. So you can see if your shader node tree gets a little out of control, there's all sorts of things you can do to help organize it and shrink it down and make it more manageable. If, however, you wanted to get those nodes back, you go to Node, Ungroup, and we've got our nodes back. So I think that's a pretty good collection of things that we can do in the shader editor as far as goofing around with the nodes. So I know we barely scratched the surface of, well, the surface socket of the material output node. However, I would like to cover at least one example of using volume and displacement before we call it a day. So we'll start off with displacement, where normal maps, specular maps, and bump maps are used to feed values into the principled BSDF to give us an illusion of depth with lighting and shading. A displacement map is actually designed to alter existing geometry. In other words, we're going to be moving vertices around. So at the same time, if there are no vertices to displace, the displacement map simply won't do anything. So before you do anything, you need to have some vertices, which is why I created a plane here and manually subdivided it a couple times. Otherwise, you can use the subdivision modifier by going to the wrench, adding modifier, and go to subdivision surface. If you go through the cycles engine, there's actually an experimental mode where the modifier will have an adaptive surface subdivision option. However, I don't think I have the processing power for it, so I'm going to forego that for right now. So let's go ahead and add our displacement map to the shader editor. And because it is in grayscale, we're going to go to the color space here and set to non-color. And then to feed that into the material output, we're going to need a displacement node, which is under vector. So add vector displacement, and we'll stick that guy right there. And we're going to use our color to change the height. So we'll go color to height, displacement to displacement, and you see it really didn't do anything. We actually do have some bump map results, but no actual displacement. So the reason for that is because the material preview uses Eevee, and Eevee does not do displacement nodes. So in order to see our results, we're going to have to go through a few hoops here. First thing we're going to do is go to cycles. So we're going to go to object mode here, and then on the far right, we're going to go to render mode. Again, you kind of see an illusion of depth, but it's purely an illusion. Over on the right side here, we're going to go to the rendering properties and change the rendering engine to cycles. Again, we get the illusion, but not the displacement. So there is one more hoop we have to jump through, and that is to add the setting to our material here. So we're going to go to the Material tab, go all the way down. You'll see we have a displacement panel. This does not show up if Eevee is set as the rendering engine. So you need to set Cycles as the rendering engine. Then go all the way down, and past displacement there's a settings panel here. And where it says displacement, instead of bump only, we want to change that to either displacement only or displacement and bump. So if we go to displacement and bump, now we see our results. So if you've ever worked with the Unreal Engine, this is one way you can create a terrain map where you create a grayscale image and the shades of gray are used to determine the height of the terrain. So how this is used in actual practice is a little bit different. I just thought this would make an interesting example. But if we have a look here, and this is from cloud.blender.org. This is an actual available texture. I think you need to create an account with them in order to download anything. But here you can see all of the different maps that you would be feeding into your various nodes. So color would go into the base color of the BSDF. Specular would go into the specular property of the BSDF. Displacement would go where we put our valley and mountain image. So that's all I've got for displacement. Next we'll take a look at a volume example. So a volume is an effect that doesn't have any hard surfaces, so something like mist or smoke or fire. And even though a volume doesn't have any hard surfaces, it does need to be contained within a solid mesh. If your mesh is not solid, where a face is missing, or maybe there's overlapping with the surfaces, things can get a little weird looking in Cycles, and I will show you what I mean by that. But first, let's go ahead and bury our checkered cube. We're going to do that by going to Add, Mesh, Cube, and then size it up so it covers everything up. Now we're already in the shader editor at the bottom of the screen, so with our volume selected, we're going to click New to create a new material. And then we're going to go ahead and delete the principled BSDF. Instead, we're going to go to Add, Shader, Principled Volume, and this is basically the volume version of the principled BSDF. There's a whole bunch of options here, and we're hardly going to look at any of them. What we are going to do is connect the volume socket to the material output there. And it's kind of hard to see what's going on, but if we change the coloring just a tad, it becomes very clear what's going on. You can kind of see our checkered cube in there with a colored mist all around it. Let's go ahead and see what that looks like in Cycles. So we're going up into rendering mode here. Rendering is already set to Cycles. You'll see when I do that, the volume is extremely dense, and this is just another example of how things render differently in Cycles and Eevee. So let's go ahead and take the density down a bit, or a lot. And there you go. You can kind of see our cube peeking out there. So if you wanted to make a volume a little bit more interesting, what you can do is go to Add, Texture. We'll go with the noise texture. And you can go ahead and plug that into the color. And it kind of gives you a little bit of variance there, a little bit more mysterious of a look. We'll plug it into density as well. I don't even know what anisotropy is, but we'll plug it into there. And the differences are subtle, but it's just one way you can play around with a volume. Now I mentioned things get weird if your mesh is not solid. And there's no reason it should be, but just to show you what it looks like, I'm going to go to edit mode. We're in face mode. I'm going to click on the top face and delete it. And you see, once I do, things look weird. If I go over to Eevee, you can hardly see anything, but if we pop the density up, you see Eevee doesn't really seem to care. We're going to connect the density back, go back into cycles, put the face back, and there we go. So that's all I really have for you today. I know we covered a whole bunch of topics at a very surface level. Probably left you with more questions than answers, but hopefully I spurred your curiosity and you're all excited to get out there and do some research and experimenting and go ahead and create some very interesting scenes. So with that, I hope you learned something and had fun, and I hope you have a good day.